Hello and welcome to the episode 4 of Code Deep Dive. In the last episodes, we talked about standard vector implementation. We learned that vector uses standard allocator in order to manage memory. In this episode, we will deep dive a bit more into standard allocator implementation. Let's create standard allocator object. Allocator is a templated class. Previously, we used integers, but this time let's use custom structure. Allocator inherits from allocator base, which is an alias to new allocator. Memory operations are based on new and delete operations. There are no attributes in the objects of this class, no direct start to manage. This allocator has only default constructor. Let's call allocate, as we are going to allocate memory for 5 custom structure objects. We'll store return pointer as it indicates allocated memory location. Let's run this. We have seen this method before. There is a check for the limit of maximum elements to allocate, and then new operator is called to allocate bytes required to store 5 objects on the heap. So 40 bytes total in this case. Let's use this memory area to put data directly. We can see that the data fills in the memory. There's a first element, and after 8 bytes, the second one. We can additionally use construct to construct objects directly in allocated memory. We'll make use of parameterized constructor in order to do that. We are passing existing pointer and calling constructor directly. When checking memory, we see that object was constructed in the 4th place in the memory. Max size function was discussed in one of the vector episodes, so let's skip it. Let's use the allocate function to free memory. We need a pointer and size of memory to be released. This operation calls global operator delete on the pointer with addition to the total number of bytes to be released. Once the function returns, the pointer becomes invalid. We should not be using it anymore. In any moment, we can get an address in the heap of an object that's stored in memory. Given the reference, we are given pointer back. In this case, we are asking about memory that was already deallocated. However, it does not matter as an end result. The last method to check is destroy method. In order to test it, let's create explicit destructor in custom structure. Let's destroy the second element in the memory. The pointer passed to the method is used to call destructor on the object. When we look at the memory, we see that data of second element was modified as a result of object being destroyed. The memory itself was not released. The release happens when calling deallocate. Mind that destructor is not called during deallocate operation. Memory allocation and object lifecycle are separated from each other. In this video, we showed how Standard Allocator works based on new operator. In the next video, let's have a closer look into move semantics. Thanks for watching.